we're moving on to direct variation. Direct variation, I want you all to put quotation marks. This means proportional relationships. Maybe let's just use the word proportional, because that might be the one that you're like, oh, proportional, I remember Miss Mahol talking about it. What you're going to be able to do today, your target, you can identify direct variation, proportional relationships, and determine a constant of variation. It sounds intense, but you know slope-intercept, you're going to be good. You know how to get things in the slope-intercept form, you're going to do great, okay? What direct variation means, let's really break this down. Direct means you get right to it, right? Variation, change, a quick change. You get right to a change. So it means here that y varies directly with x. That means whatever x does, y is going to do something, so it has some kind of relationship. Directly means you're not going to have to add or subtract something. All you do is multiply by something, okay? So you multiply x by something to get to y. This is y is equal, this box is mx. What's m represent again? Slope. So this is just y equals mx. So what would the y-intercept be? 0. I don't have to do anything to x or to the mx. A constant of variation, how is it constantly changing? It's what we multiply x by to get to y. So it's what we multiply x by to get to y. That's our constant of variation. I gave you the whole lesson in that one paragraph. You just got to see it at work. What I'm saying here, you can identify proportional or direct relationships by seeing if y is varying directly with x. That means this statement. Do we multiply x by something to get to y? You don't add or subtract something. You always only have the y and x. Here's some properties associated with direct variation. Y is strictly dependent on x. That means no adding or subtracting something. Here's how you can quickly tell if it represents a proportional relationship. You can quickly tell if there's only x and y in an equation. If there's only x and y, that means y varies directly with x. And if y varies directly with x, you have this. Y is equal to something times x. It's always going to go through the origin. Always. Because it's the plus 0. So you're going to have some kind of graph that looks like this. There's one. That's a proportional relationship. Y varies directly with x. Here's another one. Proportional relationship. Let me make it a little steeper. Proportional relationship. Proportional relationship. Okay, do you see what I'm doing here? Proportional relationship. Anytime I go through the origin, I don't know what I'm multiplying y by to get to x, but it's really just the slope. All I need you to do is find the slope. If you can find the slope, that's the constant. That's what you're multiplying x by. Okay. We're going to identify what is direct variation and what's not. What is proportional, what is not. Remember, with direct variation, there is only x and y. Only x and y should be apart. If it's proportional or direct, that means I get directly to the y. I don't add or subtract something. looking at this one here, 9x plus 3y. Direct or not direct? Is there only x and y here? No, I have the negative 1. So this is not direct because of the negative 1. I can only have x and y stated right on top here. You're looking for only x and y. 5x equals 6y, direct or not direct? Direct, because there's only x and y. 4y minus 3 equals 8x. Direct or not direct? Not direct, because y? Negative 3. I only want x and y for direct variation. 3x minus 2y equals 4. Direct or not? Not. I have the 4. I only want x and y. 6y equals negative 3x. Ryan? Direct. I only have x and y. 0 minus 7y equals 4x. Direct, because 0 disappears, right? So this is actually a direct, because the 0 disappears. So in your notes, I would list them